Good. So let's use the other side of the board. So it will take P 1.5. So let's then calculate the time of flight of P before crossing Q. What is the time of flight of P before crossing Q? Yes. What will be the time of flight of P before crossing Q? Class, I'm listening. Oh, where are you? Are you here?
Yes, please.
And what's the time of flight of P before crossing Q? Oh. Hello, I'm listening. Okay, look at it. You see, what's the time taking for P to move from the ground to the maximum height? What's the time
4
there?
seconds.
4.
4 seconds.
So 4. And what's the time taken by P to move from the maximum height to the point where it crosses Q?
1.5.
And so that would be the time of flight. So we have 5.5 as the time, the total time taken by P before crossing Q. So if before both particles crossed, P had traveled this time, then what will be the time traveled by Q before crossing P? What will be the time traveled by Q before crossing P? Yes. Yes, class. What is the time traveled by Q before crossing P? Yes. What will be the time here? Gloria, go ahead.
2.5.
Gloria, how did you get 2.5?
Please, I took the total time to be 8 seconds. Then I subtracted 5.5 to get the time from Q to me.
No, Gloria, listen. It will rather take P 2.5 to move from here to the ground. You see, when we were calculating and you use the 15 for this point, we calculated and got 2.5. You remember? You remember? What it means is that it will rather take P 2.5 to move from here to the ground, not Q. Because the reason is that because they don't have the same initial velocity of throw. The initial velocity of U is 40, but we are even here to calculate the initial velocity of Q. So it will rather take P 2.5 seconds to move from here to the ground. Gloria, are you fine?
Yes.
Good. Now, you see, the question says that P was thrown first, and 4 seconds later, Q is thrown, meaning the time traveled by Q, okay, compared to P is delayed for 4 seconds. So whichever point Q reaches, okay, P leads Q by 4 seconds because P was thrown and 4 seconds later Q is thrown. So whichever point P reaches, the time there for P, okay, P is ahead of Q by 4 seconds. So if P has a total time of 5.5 before crossing Q, then if you are looking for the time taken by Q to cross P, you have to subtract 4 seconds from the time of P, because P leads Q by 4 seconds. Akosia, Amma, Lauren, and Co. Are you okay?
Mr. Yeah.
Are you okay?
Mr. Yeah.
Hello.
So does it mean that anytime you are finding the time another particle met another particle, you have to first find the total time of flight for the first one before you subtract the time it leads?
For this particular contest, yes. Other questions, I don't know how it can be framed. It depends on the question. Okay. But for this particular question, that is how it must go.
Yes.
Are you okay?
Yes, please.
So P was thrown, and 4 seconds later, Q is thrown, meaning the time during the whole flight for P and Q, P leads Q by 4 seconds. So if they are meeting at this point, and P takes 5.5 seconds to be here, then if I want to note the time taken by Q to get here, I have to subtract 4 seconds from the time taken by P. All right. So time traveled by Q before crossing P becomes 5.5 minus 4 seconds, which is equal to 1.5 seconds. All right.
Yes, please.
Then the next question says that we have to find the initial velocity. Find the velocity with which Q is short. Find the velocity with which Q is short. Now, whenever I'm looking for vertical height traveled and I'm giving the time, the equation to use is H is equal to UT, and because Q is going up, minus half JT squared. Okay, and I'm looking for at the point where the two particles cross, Q had traveled a distance of, at the point where the two particles cross, Q had traveled a distance of
68.75.
So 68.75 is equal to U. Now, before crossing Q, what is the time taken by Q? Sorry, before crossing P, what's the time traveled by Q?
1.5.
So 1.5 minus half times 10 times 1.5 squared. So put them in. Plus 5 times 1.5 squared is equal to 1.5 U. Please don't be confused here. Here, half times 10. So the 2 cancels 10, giving me 5. So 5 times 1.5. But because it's a negative sign and I'm looking for U, it has crossed the equal to and has become 5 times 1.5 squared. Are you okay?
Yes,
I
please.
jumped a little bit. Maybe let me clear it to help those who haven't seen it to also understand. So this is what I have: 68.75 is equal to 1.5 U minus 5. What is 1.5 squared? What is 1.5?
2.25.
Okay, so because I'm looking for U, I'll make 1.5 U the subject, and so I have 68.75. This is a negative. It will cause the equal sign to be a positive. Please multiply 5 by 2.5.
11.25.
0.25.
11.25. Okay. Therefore, u would be equal to, sum this up for me.
80.
That's 80.
Yes, 80.
80 divided by 1.5. And I think this will be 53.333. Correct?
Yes.
Yes,
So that-
please.
That's the initial velocity of u. That's the initial velocity of u. Please, I picked the question from Atake, and the answers are at the back. Okay, no solution, but the answers are there. So you can try questions there, and then check at the answers. The list of answers at the back for the correct, even though the solution is not there. So this is how it must go. Any question? All right. Can I clean the board? Can I clean the board?
Yes,
Yes or no? Oh, no response.
yes, please.
You can.
Okay. Then the Archimedes principle question I gave. You see the other day I said I missed out on some one of the values. I think the density of the something. So I took a shot of the new one, posted it on our platform. Please, did you make time to look at it? If you did, we can move on. If you didn't, then we can relook at it.
Yes, please.
Which is which? Did you look at it?
Let's go.
Yes, please.
Okay. So I think the answer for the percentage is approximately 80%. It's approximately 80%. Or it's 79 point something, but it is approximately 80%. Today we'll continue with 1 or 2 questions, okay, on fluid mechanics, and then we wash our hands off it. But tomorrow I want us to maybe start something new. Yes, we can start. We may not finish though, but we can start either projectile motion or vectors. The choice is yours as to which one to pick. That's the plan for tomorrow. So you can make your choice right away. All right. An example, and I'm reading. Are you ready? Ready?
Yes.
The volume of a piece of metal, is 30 cm cube. The volume of a piece of metal is 30 cm cube. Calculate the upthrust when it is totally immersed. Calculate the upthrust when it is totally immersed in a liquid of density. 0.8 gram per centimeter cube. Calculate the upthrust when it is totally immersed in a liquid of density 0.8 gram per cm cube. Take gravity to be 10 meters per second squared. I take it again. The volume of a piece of metal is 30 cm cube. Calculate the upthrust when it is totally immersed in a liquid of density 0.8 gram per cm cube. So I think this is 3 minutes example to solve. So start with 3 minutes. One minute more. 1 minute. Juvia. Hello, Juvia.
To say,
Are you there?
yes, please, I'm there.
Okay. Otubia.
Yes, please.
Okay. Bushra.
Mr.
Bushra,
Ria.
are you there?
Yes, please.
Okay. Yaba, you also there? Yaba is not there. Can we look at it if you are true? Class,
Yes, please.
okay. So, Olivia, what did you get? Hello, Olivia. Otubia. Hey, I'm calling you. Talk to me. What did you get? All right. So the volume of a piece of metal is 30 cm cubed. So we are told that the volume of the metal let me reposition my screen, okay? So volume of metal is equal to 30 cm3. Calculate the upthrust if it is totally immersed in a liquid of density. So density of liquid. .8 gram per centimeter cube. When G is 10 meter per second squared. Class, are you there?
Yes, please.
Okay, we are calculating for upthrust. How do we calculate for upthrust? Yes. How can we calculate for the upthrust on a body in a fluid? Quick one. Yes, okay, Akosia.
M is equal to the density times the volume times gravity.
Be specific, Akosia. It's equal to, upthrust is equal to
The density of the liquid.
good.
Times.
So rho of the L
Times the volume.
volume of liquid
Oh, okay.
displaced. Very important. Times
The gravity.
gravity. And the underlined term or the clouded term is also, since mass is density times volume, this is also mass of liquid displaced times G. So don't forget, it can be this, it can be that, all right? For this particular question, we are using density of liquid, volume of liquid displaced times gravity. Do we have the density of the liquid?
Yes,
Yes.
0.8 gram per centimeter.
0.8
Gram per cubic centimeter.
Okay, so let's even bring the units for you to see something. What is the volume of the liquid displaced?
30 centimeters cube.
30 centimeters cube.
Oh, but the 30 centimeter cube is the volume of the solid. It's the volume of the piece of the metal.
It's equal to the volume of the liquid displaced.
Why? Why?
Because the object is totally immersed in the
Because
Because the question is totally immersed, and with this one, it's showing accumulated space.
that is all that I'm looking for. So the volume of the liquid displaced will be equal to the volume of the piece of the metal, because we are told from the question that it is totally immersed within. So I was just looking for the reason. Times
10.
times 10. Okay, we shall see later. You let's maintain G. Okay, but look at something. Because this is multiplying this, cm cube would cancel out. So we have 0.8 times 30, which will give us
140.
which will give us what?
24.
24 And what will be the unit left?
Grams.
Gram. That is why I said this. That's the reason why I said this is also mass of liquid displaced. So it tells you that the mass of liquid displaced is 24 grams. If the mass of the liquid displaced is in gram, then you can't multiply this by 10. You can only do so after converting the mass into kilogram. Okay, so if I convert 24 gram into kilogram by dividing through by 1,000, then I can confidently multiply by 10. Akosia?
It says here, please, 0.8 grams times another gram. Why is it not 24 grams squared?
No, this is not gram, this is gravity. Jane.
Mr. Dia.
Akosia, are you clear?
No.
This J is not gram or gravity. Gravity, acceleration due to gravity.
Okay. So it's 24 grams times gravity.
Times gravity, but you can't multiply the mass in gram by 10 unless you convert the mass into kilogram.
Yes, please.
Mr.
Hello.
Please, doing it this way, can't you also multiply it by 0.01 Newton?
Perfect. That's another option. And that's the next thing I was coming to talk about. Okay. So either you convert the mass in gram to kilogram by dividing through by 1,000, then times 10. You see here, that's what you have. By dividing through by 1,000, you have the mass in kilogram. The acceleration due to gravity is in meter per second squared. So what you have is, you have 0.1224 kilogram meter per second squared. And what is this unit? What's the SI unit of this derived unit? Kilogram meter per second squared.
Newton.
Telling you that upthrust is also a force. So instead of expressing it this way, it is also equal to 24 Newton. The other way out is that, oh, okay, I can maintain my mass. Zubia, are you asking a question?
Please.
I can. Go ahead.
I was not asking a question.
Okay. The other way out is that I can maintain my mass in gram, but because I know for every 1 kilogram mass, it would weigh 10 Newton. So if I have 1 gram mass, it would weigh 0.01 Newton. So if I have 24 grams and I want to convert it to weight, then it's equal to 24 times 0.01 Newton. And the value will be the same as this one, 0.24 Newton. That's the problem of the day. Mamie Ekuya. Mamie Ekuya, go ahead.
Mr. This is Mamiefa.
Mamiefa, go ahead.
Mr. Dia, please, I cannot see the board clearly.
Hey, Mamiefa, then it's your network, oh, because I can see it clearly. Can you rejoin? Rejoin, let's see, okay?
Yes, please.
Akosia, go ahead.
Mr. Dia, please, you said we can't use the 10 meter per second squared. So are you supposed to convert it to centimeter per second?
Akosia, I didn't say that. What I'm saying is that If the mass is in gram, you cannot multiply the mass in gram by 10 meters per second squared direct. When you do that, it is wrong. You can only multiply by 10 when you have converted the mass in gram to kilogram.
Yes, please. Understand that one. And the 24 gram. The 24, you won't convert, you will keep the 24 grams. I want to change the 10.
You
From
don't
meter.
change. No, don't give yourself more problem.
Okay.
Okay.
Thank
Hmm.
you. Yes.
All right.
Mr.
Another-
Edia,
Hello.
Mr. Edia, please, about the gravity. See the
Mhm.
second option you've written.
Yeah.
If we are not supposed to multiply the gram with the gravity, how come you were able to multiply 24 grams by 0.01 Newton? How did you get the 24? If you use the second option, how did you get the 24?
Oh, the 24, we got the 24 from here. 0.8 gram times 30. And that gave us 24 grams. So we have mass of liquid displaced to be 24 grams times acceleration due to gravity. But what I'm saying is that we can multiply this by 10 until we've converted this mass into kilogram. Right?
Yes, please.
So we got the 24
Sir.
from. Are you okay or still?
Sir,
have
please, I'm
some?
trying to say that I'm not fine. Sir, please, I'm trying to say that if we had used the second option first, the 24, does it mean that there's also a formula which says abstract is equal to density times volume without the gravity?
Oh yes, and that's the okay, you let me go right in. You see, we pick the same thing from here. Abstract is equal to density times density of liquid, this times volume of liquid times gravity. And what I've put inside the box is mass of liquid displaced times gravity. Right? So it means that whatever we got, 0.8 gram per cm cube times a volume of 30 centimeter cube times G. When we cancel, this times this, we gave us 24 gram, is actually this, mass of liquid displaced.
Yes. So, Uncle, what would the gravity run away to? If
No,
we use the second option.
It hasn't run away. You see, times gravity, J is here, but what I'm saying is that you cannot, the acceleration due to gravity is approximately 10, right? It's approximately 10.
Yes.
When you multiply 24 by 10, you have 240, right?
Yes,
right?
please.
This answer is wrong because acceleration due to gravity. Hello. All right.
Working on it.
So it is wrong because J is in SI unit, meter per second squared. Then the mass, okay, is in gram. Once it's in gram, it is not in SI unit. So you have SI unit, non-SI unit. When you multiply something like this, it is wrong. You have to convert everything into SI units. That is why we are converting 24 gram into kilogram before we could multiply by 10. But what I'm saying is that the other option is that I know that if I have 1 kilogram mass, it will be equal to a weight of 10 Newton, because weight is equal to mass times acceleration due to gravity. So if I have a mass of 1 kilogram times acceleration due to gravity, whose value is 10 meters per second squared, I have 10 Newton. So 1 kilogram mass would weigh 10 Newton. So if I have 1 gram mass, what will be its weight? Are you okay? If I have 1 gram mass,
Yes, please.
to find the equivalent weight of 1 gram, the obvious thing is that convert this to kilogram by dividing through by 1,000. So this is equal to 0.001 kilogram. Having converted the mass in gram to kilogram, I can now find its weight, which is equal to the mass 0.001 times acceleration due to gravity, which is 10. And this will give me 0.01 Newton. Okay. And this is the weight of 1 gram mass, which has been converted into kilograms. So either 1 gram mass or 0.001 kilogram mass. So all that I'm saying is that if I have 1 gram mass, it will weigh 0.01 Newton. So if I have X gram mass and I want to find its weight, all that I do is that because I know 1 gram is equal to this, just multiply the X by 0.01. So if I have 1,000 grams, okay, I don't need to convert it to kilogram before. All that I have to do is that 1,000 grams, the 1,000 times 0.01. Then I have what that will give me, which is 10 Newton. Am I okay?
Yes, please.
That's all that I'm saying.
Mr. Idia.
Hello, Gloria.
And Mr. Idia, so immediately, maybe when you started, then you wrote actual is equal to 0.8 times 30 times 0.01. Would they ask maybe where you got the 0.01 from?
Correct. Unless whoever gave you the question doesn't know. Are you okay?
Yes, please.
Unless the person doesn't know. Okay. Okay, another question. Another question. Are you there?
Yes, please.
I'm even lost. Okay. A solid body whose relative density no, hold on. Let me rewind the track. Okay. A solid weighs 60 Newton in air. A solid weighs 60 Newton in air. 50 Newton in water and 40 Newton in oil. A solid weighs 60 Newton in air, 50 Newton in water, and 40 Newton in oil. Calculate the density of the second liquid. Calculate the density of the